Hello, today we're going to be doing guided notes on confidence intervals and sample size for proportions. You're going to need your graphing calculator, your Z-chart, your normal distribution chart, and either these notes or pen and paper. So I also have up the confidence interval formula sheet that is in your guided notes folder, and it is also on from the same sheet that I did from the introduction to confidence interval videos. I just made a copy of this sheet again just to kind of fill in as we go. Okay, so proportions. So here's what we're going to do. Here's what we're going to do. We're going to do confidence intervals for proportions. What you do in a confidence interval for proportion is you go out and you take a sample and you get a point estimate, and it's going to be a little p hat. That hat over top of that p, read as p hat, tells you that you are doing a sample proportion. The symbol for p is the population proportion. This is a little sample proportion, and you read it as p hat. Okay, so that is called our point estimate, if you remember from our intro video. That is one point in time that we went out and did a sample and got a proportion. Then we're going to add some to it and subtract the same amount from it, and we're going to make it into an interval estimate. So you use your point estimate from your sample and then just add and subtract a little to it, and that makes your confidence interval. This part that you add and subtract from it is called your margin of error. Okay, so here's the formula. Your formula is p hat, and we're going to change everything to decimals. So we're going to do p hat plus or minus, and then the margin of error. The margin of error is going to be a z from the Z chart, and then another part. This part is called standard error. This is big square root. The same p hat again, written as a decimal. Q hat, which is just the complement, and then over the sample size. All right, so let's talk about what each of these pieces are. All of this in green is called your margin of error. And then in blue, this part right here is called your standard error. You have to know the different pieces. Sometimes I give you the standard error already calculated, and then you just have to put the Z in from your chart. This Z comes from your chart, and we're going to refer to this Z as your critical value. Okay, we're going to refer to that as a critical value. So those are different pieces. All right, so where does this p hat come from? Well, you go out, p hat is just what we call x over n. So you go out and you take a sample, and that sample is your total of your sample size. That's your n. And then this would be the total number of successes, of people successes. So this is your number of successes. This is really binomial from last chapter. Okay, so that's just your number of successes. An example, I go out and I sample 150 seniors and ask them if they took the SATs last week. Out of the 150 seniors that took the SAT, 121 said yes. That would be how your p hat is calculated. So these are both counts. This is why it's binomial, because it's either success or failure. I don't know if you want to call it failure, but it's either a yes or no. And so you have this must always be a whole number, and this is always your total. That's where your p hat comes from. Okay? When we put the things into the formula, we always change them to a decimal, not a percent, and not counts. So everything that goes into this formula is a decimal. Okay, the calculator does most of the work for us. So to do it on your calculator, we're going to go to the button Stat, Tests, and then one prop Z int. I think it's letter A. I'll show you when I get there. You have to put it in the calculator as your X and your N. So this is your total of your sample, and this is your count. This must be a whole number on this X. Okay, so that's the difference. In the calculator, you're putting counts in. In the formula, you're putting the decimal in. So if you were doing the calculator, you would put 121 over 150. If you're putting it in the formula, you're going to divide this and find a decimal for this. For each and every one of these problems, I'm going to require a sentence. Here's your sentence template. Your sentence template is here, and it is also on your formula sheet. All right, let's talk about where we get this Z on the chart. I talked about the other day about 90, 95, 98, and 99 confidence levels. So your Z comes from your level of confidence that you have. So if you have a 90% confidence level, what you're basically doing is taking your sample and you're finding the middle 90%. Okay, that's what you're doing. So if this is the middle 90%, change this to 0.9, that means that's 9,000. Then what we call an alpha level, that would be your total shaded area out here. In the tails, this is tail area. This is called an alpha symbol. It's a Greek symbol. It's called alpha. This would be your total area in the tails of your normal curve. If this is 90, then this is 5 on this side and 5 on this side. This is 10%. These two always add up to 1. So if you're doing a 90% confidence interval, you have an alpha of 10%. Okay, so now what we need to do is find these two values of Z, and then that's the number that goes into the formula for Z. So I'm going to look at either 500 on my normal distribution chart or 9,000. So let me go to my normal distribution chart. What I have right now is 9,000 right here, and this is 500. So I can either look up 500 over here inside the area. I can either do that, look up this little tail area, or over here I can look up this total shaded area, which is 9,500. Either way, I go down and I'm going to do the 500 side just because it's a little easier. And if you look, it is right in between these two numbers. If you want to do 9,500, it is the same thing in between these two numbers. Since it is exactly split the middle between these two, it's in between 1.64 and exactly 1.65 on both 1.64, 1.65. I'm going to split the difference since it's 1.64 here and 1.65 here. This is like 640, 650. I'm going to make it 1.645. I'm going to kind of do like a split the difference boundary. Same thing over here. It's this is on the negative side, 1.64, 1.65. That looks like 640, 650. I'm going to split the difference since it's right in the middle and make it 645. All right, so make sure you have these. You're going to use these over and over and over again. So for this one, it is going to be a plus and a minus 1.645. That is the number here, here, and here that gives me a middle 90% for my confidence interval. Okay, let's do 95%. So if I'm doing 95%, that means it has to add up to 1. This alpha level is going to be a total of 5%. Middle 95, and then 0.25, because it's total of 5%, 0.25 here, so 250, 250. So if I want to look at the closest thing up to that, I'm trying to find these two that gives me a middle 95%. Once again, this is the Z that's going to go into the formula. So I go to my normal distribution chart. Let me clear this out and trash that. And okay. All right, so this was the middle 95%. That was 250. because this was 250 over here. So I can either look up 9750, or I can look up 250 here. So either one. I can look up the left side, which is just this, or I can look up the whole right side. Either one, if you look at it and go to the closest one, it's dead on. 9750 over here, negative 1.96, 250 over here. They're both 1.96. So plus and minus 1.96. Okay, next one, change color here. 98% is going to give me an alpha level of 2%. That means that this total shaded area outside of here, which is 9,800 in the middle, confidence levels, intervals are always at the middle amount. This would be 100 here and 100 here for a total of 100%. The alpha level is going to be what we call 2%. Okay, so if we go to the normal distribution chart and clear this out, and I say this is 98, yep, and that would be 100, and that would be 100. This would be 100, and I look up the closest thing to 100, and it is 99. I look up the closest thing to 100 on this side, and it is 9. Look up the closest thing to 9,900 on this side, and it's 2.33. This is the closest thing to 100. I got a 99. This, you have to look up this whole area, which would be 9,900. And I got 9,901. One away, both the same number, 2.33, plus and minus 2.33. And then the last one, these are the 4 big ones that we do for confidence intervals. If this is 99%, this would be 1%. Remember, this is the total shaded area. So if this is 9,900, this would be 50 and 50. Because it's 1%. This needs to total 1%. That's your alpha level. Go and you look up closest thing to 50 on this side. Clear out. Where am I? Right here. Okay, so this was 9,900. That left me with 100. So 50 on this side, 50 on this side. So, oops, 50, not 500. So if I'm going to look up on this side, I'm going to look up 50. On this side, I'm going to look up 9950. So either way, you can look up either side. When you look up either side, you're going to get 2.57 and 2.58 right smack in the middle. 51, 49, we want 50. So we are in between 2.57 and 2.58. Once again, right in the middle. I'm going to split the difference. This is like 570. This is 580. I want to make it 2,575. Looking at the positive side, it'll be the same. 2.57 is 9949 and 9951. We're going to split the difference right in between 2.57 and 2.58. I'm going to split the difference and make it 2,575. Some books use 2.576. Some use 2.575. On these ones, I want you to use these two, but I will tell you that you might see 1.65 here used, and on this one, you may see any of these three use 2.578 also. So I tend to use 2575 and 1645. I have seen books use this, and then I have seen books use 1.65. So these are super important. You're going to use these each and every time when doing this. You're going to have to put usually one of these four numbers in when you're using the formula. So either memorize it or write them down or make sure you have those somewhere in your notes. Okay, example 1. A sample of 500 nursing students included 60 men. Find the 90% confidence interval of the true proportion of men who applied to the nursing program. So each of these, you need to have three answers. You need to have the numbers in the formula. You need to have the mathematical answer for the interval. And then we're going to also do sentences for those. Okay, so the formula is p hat plus or minus. I'm just rewriting the formula from the first page. Z p hat q hat over n. Okay, so there's my formula. So I want a 90% confidence interval. So I go to my Z from the previous page, and the 90% confidence interval is 1.645. And somebody said, well, which one do we use, the positive or negative? You use both. You're going to add it, and then you're going to subtract it. So it's built into the formula. You need both the positive and the negative, and that's where that's built in. So you're ready to go. All right, so we have 60 men, that's X. That's how many successes, how many male nursing applicants, and this is our N. All right, I tend to go and do the graphing calculator first and then fill in the rest of my answers. I can fill this in and say this is 5,000 because N is 5,000. But I need decimals for these. So you can do this by hand first. P hat comes from 60 over 5,000. And we can do that first. So 60 over 5,000, you can calculate that decimal and then put everything in. Or I just tend to go to my graphing calculator and do everything at once. Okay, so this is a new menu. You are going to be using something in this menu for the rest of the semester. Like I said in the earlier video, we're starting inference, and all of your inference is here. So you're going to hit the stat key, and then you're going to arrow over to tests. Every day you will be using some menu under stat test. So today we're going to do stat, hit the stat key, and arrow over to tests. Rewind if you need help on that. Then I think I told you it was A. We are doing a one sample proportion. We're using a Z, and we're calculating an interval. So A, one sample proportion. We're calculating it using a Z off the Z chart in an interval. You hit enter, and you tell it X. This must be a whole number if not given it. N was 5,000, so we had 60 men out of 5,000, and then we wanted a 90. You could put this in as 0.90. You can put it in as 90. The calculator is super smart. So all you need is the number of successes out of your total and then level. Like I said, you can put that as 0.90, 0.92. It doesn't matter. The calculator converts it. Okay, there's your answers. So there's your little p hat. See that? And your p hat is 0.012. And here are our answers. 0095 to 0145. I'm going to go to 4 decimal places here. So I'm going to go back to my thing, and that was 012. So this is 012. It calculates it for me. Okay, so then P is 012. Q is 1 minus 012. You can subtract it or you can leave it like this. I kind of change it up. My golden retriever making noises. Okay, so then I'm going to go, I need to go back to my calculator. I forgot my answer. 0095 0145. So 0095 to 0.0145. Okay, so we had just calculated our 90% confidence interval. Where do we get the 90? From the Z chart. Where did we get this? X over N. There's our P hat. P hat, Q hat is just the complement of it. You can actually subtract that or not. I don't really care. So you need to have 3 things for each interval. This, the calculator calculates this for you. It takes this and adds all of this, takes this and subtracts all of this. Now we're going to do the sentence. Okay, so my sentence for this is I am 90% confident that the true portion of male nursing students is between, okay, now I'm going to change these to percents. This is going to be 0.95% and 1.5%. So between 0.95% and 1.45%. Okay, so then you have to have also your sentence for each one. Okay, there you go. All right, so 3 points for each question. We have to have, this is 1, 2, and then 3. If you need help with the sentence, I have given you a template for the sentence. It is right here. I said I am 90% confident that the true proportion, and we were talking about male nursing students, is between the 2%. All right, let's look at another one. Example 2. A sample of 120 teenagers asked if they use TikTok on a daily basis. 64 said they did. Find the 99% confidence interval of the true proportion of teenagers who's used TikTok. All right, so why don't you pause and try this one? You do not have to copy the formula down like I do. I just like copying the formula down just so that you can kind of follow along. So here is the formula, P hat, Q hat over N. So why don't you pause the video, try this one yourself, and then start it back up and make sure you're doing it right. Okay, so P hat, 64 over 120. I'm going to go to the calculator and do mine first there. Stat tests all the way down to 1 prop z int, letter A, and it was 64 out of 120 who use TikTok on a daily basis, and it was 99. So 64 teenagers out of 120, and the confidence level was 99. I calculate and I get 0.416 and 0.651. Okay, so go back, 416 and 651. I think that was it. Let me check again. 0.651. Yep, okay. And then now I'm going to fill everything in. So 64 over 120 was 0.533. Calculated it for me. So 53% use TikTok. 99, if I look on my previous page, is 2.575. And then 53, you can write 1 minus 53, but I'm doing this in my head, so I can get 47 quickly over 120. So the calculator does everything for you. It gives you your P hat, then you just have to do 1 minus for your Q hat. You're given your total number, and then you have to provide the 2575. And then for our text box, I'm going to say, I am %, because it was a 99% confident that the true proportion teenagers who use talk on a daily basis is between, and now I'm going to change this to percentages, 41.6% and 65.1%. Alrighty, here's my example of TikTok. Last one. Oh, no, two more. Sorry. Okay. Example number 3. As part of the quality control process for computer chips, an engineer at a factory randomly samples 200 chips during the week to test the current rate of chips with severe defects. She finds that 27 are defective. Find the 95% confidence interval. All right, so P hat is going to be 27 are defective out of 212. I'm going to go to my calculator, do it first, stat, tests, 1 prop z int, 27 out of 212 are defective, and I think it was a 95. And 95. Enter, calculate. So I have 0.127 as my P hat. And then my answer is 08. Oh, that's good. 083, 082 is 0825 and 0.1722. All right, I usually take everything to 4 decimal places. All right, so here we go. So the P hat was 0.1722, so approximately 17% were defective. So 0.1722 plus or minus 95%, go back up and get it. 95% is 1.96. Big square root 1722. Too much for me to think about, so I'm just going to write 1 minus 0.1722 over 212. My answer from the calculator was I did that wrong. It's 1. Sorry, that was one of my answers. I'm doing that wrong. Sorry. 0.172. Little switch there. Sorry. Oh, let me erase this. I made a mess, didn't I? I flipped my digits. Okay. Sorry about that. So 0.127. This is 0.127. This would be 1 minus 0.127, so I don't have to do it. 196 doesn't change. Okay, and then the answer is 0.1722. I was going off of memory. Sorry about that. And, really messing this one up, aren't I? That's the upper bound. I want to do the lower bound first. 0.08252172. Wow, I missed the whole thing. Okay, there we go. Okay, so put it in, got 0.172. We can even do the 4 if we want to. And then lower bound and upper bound. I had mixed these two up in my brain. Sorry. So we can do 4 here, since I was taking everything to 4 decimal places. All right, so then text box, blue, okay, I am 95 confident true proportion is of X the factory is between, then I'm going to change that to a percent, 8.25% and 17.32% of computer chip defects. Okay, so that means that you have between 8 and 17% of your product defective. Oh no, that sounds like a lot of waste in a factory process. All right, so there we go. Last one. All right, this is a Twitter question, then we're going to go on to sample size. All right, number 4, a poll conducted in 2013 found that 52% of adult Twitter users get at least some news on Twitter, and the standard error for this was 2.4. Identify each of the following statements, true or false. Provide an explanation. Okay. So what I'm going to do here is I am going to calculate the interval first. All right, so this is one of the ones where you're given only parts of it. So this is p hat, right? Plus or minus z. And then you usually have a p hat, a q hat, and an n. All right, so we can calculate it, but look, we don't have an n, so we can't really calculate it. So we know that this is 0.52 plus or minus. And then z, we'll figure out in a minute, but that whole thing here, this is your standard error. That part is your standard error. So they're telling you that that part is 2.4%. Okay, this is the standard error. The whole adding and subtracting is margin of error. So this is 0.24 already done for you. Now, you could figure it out. This is, except you don't have a sample size. So this is 52, right? 48, but you don't have your sample size. All right, so this is adult Twitter users getting their news from Twitter, and this is 2013. I'm sure it's higher now. Okay, now we need to find a Z in A. Okay, it says the data provides statistically significant evidence that more than half get some news through Twitter. Use a level of 1%. Okay, so remember, if your alpha level is 1%, significance level and alpha level are the same thing. If your alpha level is 1%, then you're doing a 99% confidence interval. All right, so let's see what we get here. And then we'll talk about what this question means. All right, so 0.52 plus or minus. Go back to the top and get your 99. It's 2.575. And this was 0.024 from the standard error given to you. Okay, so that would be 0.52 plus or minus. I'm going to go to my calculator, clear out, and I'm going to say 2.575. Wow, I'm really messing up these numbers today. 575 times 0.024, which was my standard error. Okay, that gives me 0.0618. Okay, so 0.0618. That's our whole margin of error. That, remember, is called your ME. Now you have your ME. It's your margin of error. Okay, now I'm just going to add 52 plus that and subtract 52 plus that. So 0.52 minus 0.0618. 0.618. Oh my goodness, I'm a mess today. 0.52 minus 0.0618. Goodness, can't get a negative percent. So 4582 is my lower bound, we call that, of my interval. And now my upper bound is going to be 0.52 plus 0.0618. And my upper bound is 58.18. Okay, so let's go back to the question. All right, so lower bound was 0.45. Today was not my day, is it? So 0.4582. And my upper bound is 5818. So the question is, does this data provide evidence that more than half, well, half is 50%, of US adult Twitter users get some news through Twitter? Is half in there? Yes, it is. I'm saying that it's somewhere between 45.8 and 58.8. So it says identify as true or false. So this one is true. There is evidence at a 99% confidence interval or a 1% alpha. These two things are the same. All right. So 50% is inside this interval. And I'm saying, hey, I think it's between 46-ish and 58%. So I'm saying that it is between those two numbers. And is 50 in between those two numbers? Yes. So that one is true. All right. Let's look at the next one. Since the standard error was 2.4%, we can conclude that 96% of all users were included. No. We are saying that with 99% confidence that it's between 45.8 and 58.8. The standard error is just your actual error that you're going to help to make up your plus minus part. That is like a kind of a standard deviation. You don't subtract that ever from 1, so false. You never subtract that from 1. Okay, if we want to reduce the standard error, we should collect more data. Okay, so the standard error in a proportion one, so look at your proportion formula. You have p hat plus or minus z, and then you usually have a p hat q hat over an n. That's your formula. This is your standard error. So if I want to make this smaller, I would ask more people, collect more data. I would make this bigger. Does that make it smaller? Yes. If you divide by a bigger number, this becomes smaller. The higher your sample size, the smaller your error. The more people, you think about it as common sense, not math, the more people you ask, the smaller your error is going to be. Okay, so that is true. And if we construct a 90% confidence interval, for the same data, this confidence interval will be wider than the 99. Okay, so remember what we've said before. A 90 is going to be a smaller interval using the same data than a 99. And here's the difference. This one is going to be, for 90, the formula was 0.52 plus or minus, and then the standard error is 0.24 for both of these intervals, right? Oh, shoot. Sorry. Terrible day. Making all kinds of mistakes. Okay, so 90, the one we did was 99. That was 2.575. 90 is 1.645 if you go back to how we find these numbers. Okay, and if you think about it, a 90% interval has a middle 90, a 99% interval, same size, has middle 99. See how this one's wider? This is smaller, this is wider. A 99 is always going to be bigger than a 90. Okay? using this same data. Now, if we went and took another sample, it may change up or something like that. But based off of this sample, the 90 will always be bigger than the 90. The 99 will always be bigger than the 90. So if we construct a 90, this will be wider. That one is false. Okay, now let's talk about sample size. Okay, formula for sample size needed. Here we go. This should be done before you even do any study. So in my previous lesson, we were talking about the election coming up. So I'm doing this video a week ahead of time. So by the time you watch this election will be over, and hopefully it will be over. Who knows? Anyway, so I just want it kind of over at this point, but I'm worried about it not being over. Anyway, and people contesting and votes and not being counted and all this other stuff. But anyway, so right now they're polling for the voting. It'll be funny when you read this to see what really happens in a week, right? Okay, so you should always determine your sample size before you do your polling, okay? Or let's talk about the COVID tests. Okay, so right now we have all of these people taking part in vaccination trials, okay? The sample sizes for these vaccination trials are like 30,000 people because they need this to be super accurate for this to work. So a sample size of 30,000 people is huge, all right? The polling data that they're doing now before the election, when you read this, it'll be over, but is about 1,500 people in each one of those polls that you're seeing on the news for each one of those states for multiple companies, multiple things. The standard size is usually around 1,500, which is also really large. But remember what I said, the more people you ask, the more accurate you need. The more people you ask, the more accurate you are. Okay, so here's your sample size formula for this. This actually, if you're doing your own study, is done first. Okay, so this p hat and q hat you don't have yet. Okay, that's why the whole point is you're trying to determine a sample size to go figure what this is. You're going to use the sample size, go out and ask people, and then come up with this. So this either has to be from a previous study, or if you have no idea, like right now in the election, they're saying, assuming it's 50-50. Okay, so if you don't have a p hat and a q hat to use, default to 50-50. Your z is going to come from your 90, 95, 99, like we just showed you in the beginning. Your E is your percent error that you're going to allow yourself to have. If you look at all the polls, in the corner of all the polls, it'll say a plus minus so much error. This is your margin of error. This is that margin of error, that plus minus part. This is actually your margin of error. Make sure when you put this in to your formula that this is written as a decimal. Don't put anything in a formula as a fraction. These must also be decimals too. Okay. And then, since you're talking about people or things, this could be Petri dishes, this could be shots, this could be anything like mice, whatever. So you can't have partial things. So you always, always take whatever number you have here and always round up. I don't care if it's like a 0.01 piece of a decimal, you're always going to round that up no matter what on these. All right, here we go. It says a researcher wishes to estimate within 95% confidence, so that tells us our Z, the number of people who own an Alexa. A previous study showed that 32% who interviewed had an Alexa. So the researcher wishes to be accurate within 2% of the true proportion. All right, so we just fill everything in. N equals. Previous studies showed 32%, so 0.32. That's 0.32. Then this is going to be 0.68. These have to always add up to 100. Success, failure. And then our Z, 95% Z. Remember, that's a middle 95. So you can look up 0250 or 9750 on your Z chart. That's going to give me 1.96. I have that memorized. I use them so much. And then how accurate do we want to be? We want to be accurate within 2%. Do not put 2 in here. Change it to a decimal. and then squared. Okay, so there is no formula function thing for this. You just have to do it. When doing this on your calculator, do this part first and then multiply because this is squared. So divide, square it, and then multiply. So I'm going to go to my calculator. 1.96 was my z divided by my error. That's your add plus minus part in the formula. That's your margin of error. I'm going to square it, and then I'm going to multiply it by 0.68. This order doesn't matter. This, and then 0.32. I can do either way on that. That gives me 2,089. I round that up, right? I'm going to round that up to 2,090. Always round up. Don't even, if there's any decimal, you go up. Okay. Last problem of the day. The same researcher wishes to estimate the proportion of executives who own a private jet. She wants to be, I'm just recording the formula down again, 90% accurate. And there's no sentence with these. And within 5%. All right, so we have no p hat q hat here. We have a 90, which is 1.645. That tells us our z. And we have an error. We want to be within 5%. Don't put 5.05. We have no information about P and Q. So when you have no information, you always default to 50-50. It gives you the largest sample size, but when you don't know, you kind of want a larger sample size anyway. So we go to our calculator, we do 1.645 divided by 0.05 square times 0.5 times 0.5, enter, you get 271. This one's lower because you're allowing yourself less confidence and higher error. So you have a lower sample size. This one had such a high sample size because you had a lower error and you had a higher confidence. Okay, so that's the first section. So let me fill in these formulas again. So proportion formulas. Here's your formulas for your standard formula for anything you're doing. You find the confidence interval when they ask you the question, find the percent confidence interval, what is the interval, construct the interval. Any of those questions will help you with that. So this one is p hat plus or minus z, proportions always use z's, and then p hat q hat over n. Remember that this piece is called standard error, SEC, that's your standard error, and then you have the Z and T. When you add, oh, I did that wrong. Shoot. Oh, I didn't want to do that. Standard error is this piece, sorry. Then when you add everything on to it, a whole plus minus part, that is your margin of error. To get this on the calculator, you're going to go to stat, arrow over to test, the rest of your term is there. And then you're going to go to A, letter A. Most of you, it's going to be letter A, but you're going to go down to 1 prop Z int on your calculator. Remember that your X has to be a whole number. If it's not a whole number when you multiply it, then make sure that you turn it into a whole number. And then you have, and then here's your sentence templates for both of the sections that we're going to be doing. And then sample size, this is, hey, how many people do I need? What's the minimum sample size needed? What sample should the sample be? How large a sample do you need? Any of those questions. If you're doing a proportion, proportions always use these. And then this formula for proportion is P hat Q hat Z over E squared. And remember, you default to 50-50 if you don't have it, and you always round up. Make sure you put this in as a decimal, not as a percent. I don't know why a lot of people make that mistake. All right, so the two formulas that you need to do section on confidence intervals. That is it.